So, just arrived at Nicholson, and my friend John and Eric are here waiting for me. So they're here. 1 second. Hey, John.
Hey.
Eric, how are you doing?
Good.
Can we get a tour? Take a look inside?
Come on in.
John, where are we at?
Well, we're at the front door of Nicholson Manufacturing right now.
Okay. What is Nicholson? What do you guys do?
Well, we make the world's finest ring debarkers.
Ring Debarkers.
Ring debarkers for
So-
taking the bark off trees.
So, John, I'm gonna get in the shot here. This is my friend John. Eric. John, for my YouTube channel, the podcast is called Wood World. Where in the wood world does Nicholson fit in?
We're at the front of every sawmill. Well, I shouldn't say every sawmill.
Yeah.
Most every sawmill in the world
Yeah.
will have a ring debarker in the front of it. And if
And-
they don't, they should.
And as it sounds, it's quite simple. It debarks. It takes the bark off of a tree,
It takes the
which
bark
is
off the
really
tree.
important.
That's right. And if you want to point a picture up here,
Yeah, I will. Let's show them.
here we go. Right here is the ring debarker. So this is what takes the bark off trees.
Yeah. And then these arms, they have like a really sharp knife tool tip on them, right?
That's right. Yep. So that's what takes removes the bark through the cambium layer off the log.
And there's a whole bunch of technology, and it has to be robust. And
Oh,
give me the high level.
so RA8, 3-inch thick steel, just super solid.
Wow. And it has to be robust because, I mean, how heavy is a log? Especially when it's wet. It's like crazy heavy.
Crazy heavy, like
Several tons.
Several tons.
Tons.
Yep.
Yeah. And so you gotta like hold on to it and then swing these sharp knives around it and do what you do, right?
That's right. So the debarker itself lifts the log up. The ring takes takes a beating.
Yeah. Well, look, I've been to a lot of sawmills all over the world, and I've seen a lot of green Nicholson machinery out there.
Yep.
So you guys do a good job. I imagine if we looked at a map, we'd probably have pins all over the
All
globe.
over the world. All over
That's
the world.
incredible.
Yep.
That's incredible. Well, excited to be here. Thanks for having me.
Thank you.
Let's take a tour.
Cheers.
Thank you. All right, I'll follow you. So as we walk into the front door, what I'm seeing already, John, is that one of the videos that we at Koval had made for you guys?
That's the Koval video.
Is it right?
Yeah.
Well, can you show us a little bit?
Yeah,
All right,
absolutely.
I'll follow you.
I'm going to let Eric talk you through it though.
Okay, perfect.
Safety gear first.
All right, let's do it.
Okay.
But John, that there is.
Yeah, so there's a log going through debarker as we speak.
All right.
And there's the ring coming out. This is a great video. We're so happy, honestly.
We'll talk about all that later. Thank you so much, John. Okay, excited for my tour. Am I going to Eric's office now?
You're going to Eric's office.
See you in a bit, John.
See you, mate.
Okay, let's get you some safety gear.
Okay. Getting the behind the scenes tour of Nicholson. Okay.
Okay, this is the assembly shop. I think the guys are on lunch right now, so it's quiet.
Perfect.
We'll head back to fab. That's where it all starts, and then we'll work our way back through assembly and the machine shop.
So let's back up to the high level again. Like, why does somebody need a debarker? Why do you need to take bark off a tree to begin with? Why can't you just, cut it down as it is?
Well, the bark comes off. It's, the bark's not a desirable process when making the product, whether it's chips. I mean, for chips, they have quality and they don't want any bark in the chips because it decomposes. They want like the white fiber. And for a sawmill, they want just the white fiber on the wood. They don't want the bark. The bark can often be, I believe, hard on the saws and the chipping heads in the canter line. And I guess it makes the log overall smaller, which is good because they can put a larger piece of white fiber through the saw line, so they can kind of maximize the white fiber they're putting through rather than having a smaller white fiber with a bunch of bark on the outside.
So there's a purpose for it.
Yep.
But it's easier to cut, like to simplify it. Like, again, the people watching this video are going to be somebody who maybe never heard of sawmills before.
Okay.
And so you're not necessarily preaching to the choir when you're talking to me. Like, imagine I didn't know. and I'm just a high school student that's interested in like a, what is this all about? Kind of like take me back to the 101, you know?
Okay.
I mean, we'll definitely get into the geeking out about the wood, the wood or the metals of how you actually make what you make. Because I was a mechanical engineer by trade. That's my training.
Yeah.
And so I love all of the fab. I love. Holy crap! This is definitely amazing. How thick are these plates, man?
3-inch.
This is a 3-inch plate.
3-inch plate. Yeah. 3-inch plate. So our A8s all use a 3-inch plate for the backbone of the machine. So 3-inch plate here and a 3-inch plate here.
So this just looks like a giant frame, right? I mean, I can kind of see the beginnings of a debarker, but I guess can you walk me through what we're looking at?
Sure. Yeah. So this is the start of a debarker that happens. It's like the backbone of an A8. This is our high-speed debarker, basically.
Wow.
It starts out with a 3-inch main plate frame. We have the two 3-inch main plates. And inside here, this is actually where all the logs go through. So the feed rolls would be in here and clamping the logs. And the logs would go through here. And on this side are all the mechanical components for driving the feed rolls and moving the feed rolls. And in the center of this whole thing over here.
This is incredible, John. Or I mean, Eric.
The ring goes in. So the ring slides in here.
So it's called a ring debarker.
Ring debarker.
That's what John was telling us up front.
Yep.
And a ring is it literally is like a giant
A big spinning ring.
circle. Okay.
So the big ring just sits in here.
How big is the ring?
This one's probably a 27-inch, maybe a 31-inch ring. So
Is that the diameter of the
that's
log that it'll
diameter-
take?
That's the diameter of the ring. So
Oh,
on a debarker, just like general knowledge, like the ring size, if it's a 31-inch debarker, it can take up to a 29-inch log.
29-inch log.
Yeah, so 2 inches less the ring bore is the size of log you can take.
Okay, makes sense.
Yeah. And then over here, this is what you call the carrier frame. So this is what holds the ring, basically. So the ring sits in here, and this whole thing's basically like it's a cartridge that slides in and holds the ring in the debarker.
This is giant. And you've got like some bearings and stuff like that you use to make sure the ring does what it needs to do.
There's one massive bearing, an air seal bearing. So that bearing, allows it to spin, and it also forms an air seal because all of the knife arms are controlled by air pressure.
Yeah.
So on the fly, the knife arms can change pressure, which is basically how much force they have for debarking to adapt to different bark, frozen, wet, dry,
Right.
green. Type of season. There's sometimes the log has a lot of bark on it, sometimes it doesn't have much bark left on it at the end, so the debarker adapts to the logs going through to give you the best debarking possible.
Experience? Yeah. Wait, so can you quickly tell me a little bit about, I guess, more about the debarking process? Now I'm curious, you mentioned different, I mean, it only makes sense that different seasons, different amounts of moisture inside of how much a tree sucked up inside, right? All that affects. I guess what are the main factors that affect debarking or your process?
The species is a big one. What species of tree you're trying to debark? Like some species are, say, fairly straightforward.
Yeah.
And then some species get a bit more complicated. We call it stringy bark. That'd be cedar,
sequoias and stuff.
Yeah, sequoias, cedar. Cypress, eucalyptus, it's all stringy bark. So those ones are a bit more difficult to debark because the bark's stringy. So if you try to debark it, the bark just comes off in big balls and gets into a rat's nest.
Oh, right.
So
Instead of breaking into little chips,
pieces,
it'll be like long,
big long
stuff.
stringy things. So on those ones we have...
You need to cut them or something
We
somehow.
cut them. We have, we call it a tandem ring debarker. So you'd have two rings. The first ring would have what we call slitter discs or pizza cutters, and they look literally like a pizza cutter. It's just you have a bunch of arms with big pizza cutter discs. They go around and score the bark and break up all those long fibers. And then the second ring comes on, and it just debarks it like normal, but all the big long strings are cut, so the bark comes off in manageable pieces, and it can be, taken away by the waste conveyor.
That's so cool. Hey, while we're here, nobody's here. Can you take a quick picture of me in front of that giant thing?
Yeah, for sure.
Or if you don't want me inside of it, then the outside's fine too.
No, you can go. Yeah, go ahead.
Here's my phone for you. Okay. Social media content. You guys see there on the YouTube channel what I'm doing? Going all these lengths for you?
Yeah.
Okay, so where can I stand? Where the ring would be?
Inside, yeah, if you want to.
Let's start here.
Start there. This way, does it matter?
Both. Closer, farther away. And then in action, I'll be talking to the camera too here for a second. So we're at the Nicholson facility, and right behind me you see a really large steel frame. Is it steel?
Steel.
It is steel. So this is a heavy duty frame. And let me tell you, here's me holding on to just like the main of the frame. The main frame here, I mean, look, it's like the size of my fist. That's 3 inches, and that's some heavy plate right there. And then here's where, would the log be going through that way or coming towards me here? It doesn't matter.
This one, I can't tell yet.
Okay, so we don't know yet, but the tree definitely goes in this area, because back here you got all the components you were saying, right?
Correct. Yeah.
Wow. Let me take a quick walk around it too then. I saw it at the Ligna booth, or something like it, and there was a lot going on. So you kind of don't want to make mistakes on drilling or doing anything, because it's like all one, right? Like you don't want to make mistakes because it's like just this solid freaking frame.
Yeah, I mean, we put a lot of time and effort into making sure that it's,
quality,
correctly,
yeah.
machined correctly.
Holy
All these
smokes,
bores
man.
and stuff like that are critical, because that's where all the pivots go. So everything's important that's in the right spot.
Wow. Very cool. Alright, ladies and gentlemen, I'm inside of a Nicholson Debarker that's getting assembled right now on the shop floor. And behind me we have my friend Eric. I just need to take a minute to process how violent it's going to be, inside, what all happens to all the mechanics. Or wouldn't you would probably describe it differently than violent.
I would describe it violent. The first time I went and saw a Debarker in the field, I thought it was a very violent process. It's banging and clashing, not because the machine's not supposed to be doing that, but just you have this several ton log going through the machine at several hundred feet per minute, and you're mechanically stripping the bark off of it as fast as you can physically, do it.
Wow.
Yeah, it's a very violent process. I remember the first time I did it, actually, I was, we're standing close to the Debarker, and it was one of those situations where I was like, I should probably stand a few feet further back than this.
Wow. I'm just taking it in. I don't think I've ever been inside of one that's, I've definitely never been here before, so it's under construction.
Yep, this is where it all starts. I mean, we cover this one now. This one will probably take about, the Barker takes us about, I think to build one takes us about, from push start on the computer to shipping it out the door to the customer. It takes about, I think about 2.5 months.
Wow.
To build the Debarker.
Wow. And they're more or less standard or a little bit custom?
They're more or less standard.
Yeah.
There is some customization, but the customization is usually within the options.
Options of it. What are some typical? What's the most popular type of debarker, and then what are the common options?
I'd say the most popular type of Debarkers are A8. This Debarker here is our most common.
This is an A8.
This is an A8. This is our high-speed Debarker. This is what a high-speed sawmill would use, or somebody pushing through a lot of logs in a day. The most common options these days, I would say, are hydraulic roll controls is fairly popular. Like standard is pneumatic roll control.
Okay.
Hydraulic roll control is faster to react. It's than the pneumatic roll control, and there's also some power savings to be had with
Yeah.
the HPU versus running a big compressor for the pneumatic roll control.
Yeah.
And
And
then-
sorry, both softwood and hardwood sawmills both need Debarkers, right?
They do. So this would be for softwood. You
Yeah.
wouldn't find a hardwood application that would use an A8, most likely not.
But you do have hardwood debarking as well.
We do have hardwood debarking as well. This is called a fixed ring debarker, so the ring stays in position and the logs are manipulated to get centered on the ring and go through. And we also have our sliding ring debarkers, which would be like our R2 and A6 and A1. And those ones, the logs go through on a conveyor and the ring moves to center itself on the log. So those would be hardwood application machines.
Okay. Wow, thank you so much. Actually, can I stand here and get a picture from in here?
Oh yeah, go ahead.
No, I mean, you have my phone, right?
Yeah.
Can you take a quick picture of me in the machine?
Yep, no problem.
Thank you. Standing here again inside of the Debarker, getting some footage for social media, for the YouTube channel, and just very curious about how it works and how it runs, how you build it, what it does, and the whole thing. So hopefully the channel likes it as well. Man. And you guys have how many years of like experience doing these machines? Like when was the company originally like started or?
Well, I think we're coming up to 75 years now.
Wow.
I think we're pretty close to 75 years of Nicholson. So I've been building Debarkers for a long time.
You got a lot of experience and reasons for why things are done a certain way, etc.
Yeah, I mean, a lot of the design is, very, very thoughtful and very calculated at the beginning, but there's also a lot of components of the machine that were learned through trial and error. Basically,
Yeah.
what works and what doesn't work, and this A8 is kind of a combination of those two. This A8's been around for close to 20 years now,
Yeah.
and it's a great machine, and it works really well.
Does what it needs to do. Takes the bark off trees.
Takes the bark off trees.
So tell me, now that we're in the plant, let's use our time here. So tell me a little bit about like where does this start? How do we get to this point? Are we first, plasma or lasering out? Looks like this is probably not laser, is it? Plasma.
This is plasma. Yep, plasma cut. So all the plate is cut. We basically the Debarkers, we get a plate kit, so it's a complete kit for a Debarker. All the plate comes in as one package for one Debarker, and we have vendors that cut all the plate for us, and they also form many of the components as well. It comes to here, and the first step is fab. So fabrication starts tacking the components together, get everything plumb and square.
Yeah.
Goes to welds it all out, and
Yeah.
then goes back and forth to machine a couple times to the machining centers, because some of the components are so big we can't machine them when they're fully assembled, so we do some machining, and then it goes back to weld and it gets expanded on and made larger.
Wow. I mean, it's like building Legos, like step by step by step.
Pretty much like building Legos, yeah, like adult-sized
Adult-sized Legos. I mean, I build Legos with my kid, and you just like start with one component, and you
Just keep adding on to it.
Keep adding on, yeah.
Keep adding on to it. Yeah, we've actually, having a Debarker out of Lego would be pretty cool. We thought of that at some point, but need some more time.
Let's do it. Have people build their own Debarkers, right? What else happens here in the shop if we're in this shop here?
Yeah, so we can go over, let's go over this way here. Actually, you can show you the welding robot.
Yeah, I'm following you.
Okay.
Eric, this is so cool, man. I'm like geeking out. Like, because I love the industry, I love the mechanics of building machines and the whole thing.
So this is our robot welder. It does a lot of the, like any welding that requires like turning or basically more complex welding. So you can see this is a control arm for a feed roll here, and yeah, it welds. Does all these big, big circular welds that would take, to get that kind of consistency by hand would be pretty much impossible. You can see up here. So these are all done by a robot.
Wow.
And then.
So somebody has to program the thing, right?
Yep. We have a couple guys here that program it, and yeah, they do all the programming, and every part gets, for a Nicholson gets welded on this robot. This is actually a fairly new robot. We've had this one for less than a year now. The first one we had, I think we had it about 20 years or so, 25 years. And we upgraded to this new robot.
Where's this component going into?
So this one is what holds on to the feed rolls. So this goes into the side that had all the kind of mechanical components for
Yes.
moving the Debarkers. So this goes on that side. It holds on to the feed roll, and you'd have like the hydraulic or pneumatic cylinders would be connected to it to control how, opening and closing the feed rolls to clamp around the log.
Yeah.
So after this would go to probably the stress relieving oven. So it would get the stress relieving done after welding.
Right.
And then after that, it would go to final machining, and then to assembly and paint.
Those are some clean welds, man.
Yeah, that's the.
But you still need human welding somewhere, right?
Oh yeah.
It can't all be
Oh,
It
yeah.
can't be robot because it's
No,
not as
no.
efficient.
No.
You need like high production or a lot of components to be in a program to make sense of robot, right?
Yeah, and these are they're tacked together by hands. Humans put them together, tack them together, and then they go onto this robot for final weld. And it's only specific components that get welded out on this robot. Like anything to do with like sort of circular welds is all done by the robot. Like our feed rolls are done by the robot. These control arms are done by the robot. Feeder rings, the actual debarking ring itself, like the huge, you can be 6-7 feet in diameter. You have a weld, a 6-7 foot diameter weld.
Yeah.
Those are done by the robot just to get the consistency and a good quality weld that you need, basically.
Makes sense. Wow. I haven't seen a machine. Well, actually, you see these in like car commercials a lot of times, probably, right?
Yeah, like a car plant would have a very similar robot.
That's pretty cool. So when people think of the wood world or the wood industry, they think of jobs that are not super high tech. They're probably thinking it's two guys with a sawmill. Like for my Africa project, they're thinking it's like people, pulling a saw up and down through a tree.
No, there's a lot of tech. I mean, even the crew that does the welding, like the team that does the welding, they're certified welders, but they also get to interact with the robot. They're programming the robot. They do a lot of troubleshooting. We're always trying to bring in new technology. So when we want to bring in new technology, we always involve the people who actually do the process, so they get to help investigate and figure out what solutions need to be brought in to help fix the problem, fix what we're trying to change. So there's a lot of technology, both on the shop floor and then in the office as well. The engineering department, and everybody gets involved.
So there's a lot of jobs around the wood industry that aren't necessarily guys actually cutting the trees or cutting the trees down in terms of logging, or in the sawmills processing the making lumber. It's a lot of jobs all the way back through the supply chain to here. What kind of jobs are people able to get with Nicholson? I mean, you're working here. Why do you work here, and what kind of jobs have you kind of come up through? Or
Okay, so I started here. I started in the engineering department.
Yeah.
I'm a mechanical engineer.
Oh, wow.
I started out
right here, man. Same.
Same
Boom.
thing? Okay.
Yeah.
So I started on the mechanical engineering side and like designing the equipment,
Sure.
working on new projects and implementing that. I worked on the engineering side I was at Nicholson here for about, I think, 6.5, 7 years in the engineering department.
Yep.
And then in the engineering department, you kind of got your fingers in several pies because people come to you with like problems and like questions. So you have a pretty good idea of what's going on in other departments. And a sales role came up.
Yeah.
And I jumped at that opportunity to jump into a sales role. And I did that because...
Can we walk and talk at the same time?
I say that the sales of like equipment like this, which is it's similar across all aspects of machinery for the wood industry. It's very technical.
Yeah.
There's a lot of you get to really interact with the customer. The customer comes to you with a problem, and it's a very technical problem, and you get to work through this technical problem with them, like come up with potential solutions, and there's a lot of back and forth. Customer site visits, working with them, and you don't get just to work with the debarker because you get to, how the logs are brought to the debarker, how the logs are conveyed away from the debarker, so you get a bit of a big picture of what they're trying to solve, and I find it quite rewarding to help out people, and in the end they get a solution that works for them, and the customer's happy, you're happy, and yeah, it's an enjoyable job.
Yeah. Well, I relate to that because here, let's face this way for a second. So I want to get the cool rolls and stuff in the background. So I can absolutely relate to that because when I was working at 3D scanning, that we were the eyes of the systems, right? So where are you gonna? I don't know if you guys use scanning on the front end of it.
Yeah, we have light curtains.
But you have a way to know how big of a log, and that's kind of important.
Yep.
I guess I don't want to speak for you. Could you explain quickly why measuring a log or having eyes in front of the debarker is important?
So yeah, the logs coming in, they can vary in length, they can vary in diameter. So in anticipation of that, the debarker, to operate quickly, the debarker needs to sort of pre-position the feed rolls to get ready to clamp that diameter log.
Sure.
So the light curtains at the entrance of the debarker scan the log and give the debarker the diameter of log. And they also know the speed of the log, so the feed rolls can open up just enough to accept that diameter of log and then quickly clamp on it because you want quick clamp pressure so that they get a grip on the log.
Yep.
Because as the log goes into the ring is spinning and it can put an incredible torque on the log if the log is not tightly grasped in the feed rolls.
Yeah.
Because you want the log to go through. You don't want the log to spin. You want the ring to do the spinning and the log to go through. So the scanners at the front basically prepare the debarker for what it's going to be accepting as far as log size going through.
So I was just going to give you an analogy. Thank you for that explanation. Makes sense. So I was working on not light curtains, but 3D scanners, right, for the sawmills. And like your story, personally for me, I share this publicly too, but just the point of I was able to go to the sawmills and hear and see while we're installing these scanners, we were able to see we could do this better, or this could be improved. And repairing scanners as an intern, I was able to take all that. And likewise, I also got a mechanical engineering degree then, and I was like, okay, cool. Well, now I get an opportunity to build implement all of those things, all those data points, basically, and build a whole new product line that then serves those customers better. And I love that.
Yeah.
I think we're in absolute alignment about I think something I really enjoyed, and you kind of touched on this, is that the jobs in our industry are, well, you can be behind a computer if you want to all day and be programming or whatever. Or in my world, it was 3D designing, modeling, and everything like that. But I really wanted to go to the trade shows. I wanted to meet people. I wanted to go to their factories and see the installations and wanted to go out there. So do you have an opportunity to also go to the field much? And
yes. And
do you enjoy it?
I enjoy going to the field. I enjoy, it's pretty interesting going to these sawmills because a sawmill, or it doesn't have to just be a sawmill, a chip mill, but it's still such a mechanical process that it's very high tech, and there's a lot of controls and a lot of technology that goes behind it, but it's a very mechanical process still. You're taking this log and you're turning it into, at the end, it's turning into a finished product, whatever it is, lumber or chips. and there's just so much going on, and it's really cool just to go in and just see. There's so many things going on at one time. There's so many levers and arms and saws and motors and pumps and conveyors and dust extraction and lubrication systems, and it's endless. And there's things always running great, and there's things that are always breaking, and there's people going in between, making sure the things that are breaking start running great, and make sure the things that are running great aren't breaking.
Yeah,
and maintenance, and you just get to. It's just if you're into mechanical things, or just it doesn't even regardless of that. Anybody going in, it is quite a cool thing to see.
It's fascinating.
It's fascinating because like there's not too many places you can go into that have that kind of density of mechanical processes going on in that kind of square footage, and the size of the logs coming through and how quick they go through.
How quick do they go through a debarker typically? What would be like a low end and a fast?
Okay, on the low end would be something like maybe 50 feet per minute.
50 feet per minute, okay.
50 feet per minute.
Yeah.
On the high end, you'd have probably up to like 600 feet per minute.
You get, wow.
Yeah. So 50 feet per minute, that would be like a hardwood mill. That'd be one of our sliding ring debarkers. So that'd be a small, more ma style mill that would be running the logs through, just slow and steady, taking the hardwood bark off and then working with the hardwood logs after. And then on the high speed end, our A debarker, which we saw before, you can get up to like 600 feet per minute.
Wow.
And that would be like high speed production, like a stud mill.
Yeah.
Softwood.
Yeah.
Spruce pine fir, and they're pushing them through as fast as they can to get production up.
I mean, if you kind of zoom out enough, logs and the whole sawmill, it becomes like, imagine like little toothpicks, but when you really back up and you look from like when I fly drones or whatever, in the factories or outside the factories, they look like little toothpicks. But if you really realize and zoom in, I mean, these are multi-ton mass that has to move quickly, and that's why you need the rigidity of the frame and all this other stuff.
Yeah, I mean, the logs have so much. They have a lot of energy. They have a lot of kinetic energy. The logs are moving. Like you have this
momentum right there.
You have this. You can have a 30. The biggest debarker we make in the 8 to 35 inch. So you can have up to a 33-inch log that could be 50 feet long, moving at 250, 300 feet per minute. Like the amount of energy that has, and if something is not perfectly timed, it's going to crash into something, and it has to be able to withstand that collision. It can't break. So everything we build, and I'm sure all companies who build stuff for a sawmill, it has to be extremely robust, and like that's why it looks overkill. You see the 3-inch plate, like wow, this thing looks long, but when you have logs going through that fast, and how violent of a process it is, and if someone's never been in a sawmill and they get to experience it, you'll quickly realize why everything is oversized.
Yeah, makes sense.
Yeah.
It's fascinating. How many people do you guys got working here?
Here at the Sydney plant, we have, I think probably about 100, 110 people working here on Vancouver Island. We also have a plant down in Pell City, Alabama, which I think has about 30 people. They do manufacturing of consumable parts. And we also have some warehouses throughout the world that have, half a dozen to maybe a dozen people working in the warehouse.
What do you have? What looks like a kiln?
So that's the heat treat oven. So that's what does the stress relieving. That feed roll control arm you saw on the robot welder. When you weld something, you introduce a lot of heat, and it distorts, and the metal part will twist and sort of go into a state of stress. So after you've done the welding, the part goes into
annealing, isn't it what it's called or something? Or whatever the technical terminology is.
Well, it's like stress relieving, I think maybe.
Well, somebody watching on the YouTube channel, if you guys know, put it in the comments, right?
Yeah, there you go.
There you go.
Somebody who's more knowledgeable than I. It goes in there and it's stress relieving, and the part will relax. All the internal stresses relax.
Right.
So the part's no longer under any stresses. So then once we do final machining, it's not going to move after. It's going to stay in that.
Eric, again, what's fascinating to me is we have to consider all these things, and to you it's like another day at work. But for me and somebody that's watching from who knows where in the world, can you imagine how much like metallurgy goes into making this giant thing that then takes barks off trees? And it looks like there's so much behind the scenes, right, that people don't even realize.
There is a lot behind the scenes. I mean, it's
A lot of science, a lot of math,
a lot of
physics.
science, a lot of math, a lot of physics. Like I said, a lot of trial and error as well. Like
Wow.
that's a huge part of it. Just like the decades and decades of experience of doing it. Like what works, what doesn't work.
Can I ask another question? Tell me more about, can we look at some of those tips? What does the knife actually look like? Like, what do you put on the end of the arms to actually rip the bark off? Is that, I'm sure that has a lot of technology and science on it too.
A lot of science, a lot of technology.
Because that's the whole point of the frame, is to position a knife really cutting edge, and or I don't even know how to describe it in words, but what's the process, and can we look at some knife tips, or what are they called? What's actually contacting your
Yeah, the
your
knife,
bark?
we call them the knife tips. We can go check those out. Those are,
And do you, I remember in the video that we made for you guys, you were explaining how it's like additive manufacturing?
so we have our older, like our more like traditional method of making, which is you have a metal,
I'll follow you. Yeah,
you have
let's
a metal
go.
blank,
Show me.
and then you have some carbide, we call them like carbide chiclets that are soldered onto it.
Okay.
And we've moved into like 3D printing now.
Holy
so,
crap. This just keeps getting better and better.
so
Wow.
You still have you still have a metal blank.
Yeah.
And then instead of the carbide material being like a solid chunk of carbide and soldered on, it's actually printed onto the blank, basically using a.
Can I?
Oh yeah, go ahead.
I mean, this is absolutely incredible.
So this is where this is the robot welder. Like that's all robot welder. This is all robot welder inside here.
Inside too?
Yeah, well, just that big cylindrical, like to get a big cylindrical consistent weld like that. The guys in the shop tack it all together with the
That
robot
is
welder.
beautiful.
Like the guys finish off the ends and stuff like that.
Right.
But this is all the robot welder, just to get that kind of consistency.
These are some gnarly looking teeth, man. Like I wouldn't want to be that log.
I think these are our 35-inch feed rolls. So this is like, yeah, this is a 35. So this is the largest feed roll for A8, and then this is a smaller one. This one is a 27. So we have even smaller feed rolls in this one, but this is the large, this is the medium, and then we also have a small.
But I mean, like, it sits on its own pallet. It's that big, and this is a roll that's going to be inside where I was standing, basically.
So each A8 has 8 of these, at least 8.
Is that why the number 8? A8?
I actually don't know why it's called the A8.
Okay.
I don't know. I'm not sure.
All good. Man, thank you so much for the tour. This is...
Yeah.
Like, see, the point is, I personally am super curious about all this stuff, like, and that's why I started the YouTube channel, because I feel like it's only fair if I take a little camera with me, and if it's cool with you guys, then I post it, and John gave me the good to go, so.
So this is what we saw getting welded out. This is the assembly stage here. This was on the robot, so these are the feed roll control arms.
Feed roll control arms.
So and after the machining, then they go to assembly, and they get put together.
Yeah, but I mean, like, just for scale, like, this is my foot. That's serious.
Okay.
All right.
Okay.
Oh, there's another frame.
Yeah, do we want to go to the tips now?
Yeah,
like,
perfect.
To get the one across boat.
Yep.
Probably.
Still have to make the fair. I can't believe you guys are making all. I really can't believe that you guys are making all of this on an island. Right? Like,
everything has to come over on the boat and everything has to leave on the boat. Unless we sell a debarker on the island, which does happen. But.
Oh yeah?
Yeah.
How many Debarkers do you have on Vancouver Island?
We probably have, let's see, we probably got like 1, 2, 3, 4, probably like maybe
At least a handful.
Yeah, like 8.
Seriously?
Maybe 8, 10 Debarkers on Vancouver
If it
Island.
isn't a secret and you can share a number publicly, how many like Debarkers are there? Hundreds or thousands or tens of thousands out there? Or
there'd be thousands. I mean, we're just building serial number 8,000 right now.
Wow.
So that's Nicholson serial numbers. We also build conveyors, and Nicholson built all kinds of things actually back in the day that were beyond Debarkers. But nowadays we focus on just Debarkers and conveyors.
Right.
So it would be thousands for sure.
Thousands, wow. And globally, not just in Canada or the North America.
Globally, yeah.
Wherever there's green on the globe, I like to say, right? Wherever
Yeah,
on a
green.
globe there's green, there's trees growing.
There's trees growing.
And people harvesting those trees and doing stuff with them.
Yeah, and there's most likely a Nicholson there. You know, anything that's made from wood, like wood that goes through a debarker, not like a palm tree or something like that,
Sure.
is at some point it's most likely gone through a Nicholson debarker.
Wow, okay.
Or another debarker at some point. It's
Yeah.
gone through a debarker.
Yeah. You gotta take the bark off. Okay, I'm following you.
So
So now we're gonna look at tips, right?
yeah.
So as you can imagine, so much mass coming through a machine, you have to build a very robust machine to hold it. And then the whole point is that you're taking the bark off. And let's turn this camera around, show you what we're looking at here. What are we looking at?
So this is one of the knife tips of our debarker.
Wow.
This is call that a 3 3/4.
Yeah.
And this is the 3D printing we're talking about. So you can see
Wow.
the carbide material is actually printed onto the blank.
Wow.
And up till now, we've typically soldered them on, but
Yeah.
this is sort of a new technology.
Can I hold on to one?
Yeah, go ahead.
It's nice. Nice little paperweight. That is so cool. Could I take one as a paperweight?
Take one as a... Not this one.
Not that one.
We might be able to find you one if you
Just
want.
one that's broken or something.
Yeah,
That'd be super
yeah,
cool. It doesn't even have to be
yeah.
sharpened, right?
Yeah.
Like
We-
put it
we-
on my bookshelf and say Nicholson.
Yeah, we do have a bunch of like kind of like test ones basically.
Yeah,
So
that'd be cool. Like a little souvenir.
Yeah,
I
definitely.
don't
Oh,
care
yeah.
about trinkets at the souvenir shop.
Yeah,
I want one of your Nicholsons too.
you don't want a pen, you don't want a benchmade knife, you want a Nicholson pen.
I do.
Okay. Yeah, we can get you one of those.
Love it. So where's the actual printing happening?
That happens here.
Guys, 3D printing.
So there's a laser head in there, and laser deposition, and it prints the carbide material onto the metallic blank. Right now,
You just said something super smart. Can you say that again? Like, what happens in there?
it's a laser deposition process.
Yeah.
So it, a powdered metallurgy
Yeah.
comes out through the laser head, and the laser fuses the material to a metallic blank.
Wow.
So it actually bonds. It makes a bond between the carbide material and the metal base, and that's what's printed onto the 3D.
What's this
knife
whole process called? Like, if I was to go Google it,
tips. We call these ones our MLX.
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 Yeah.
So there's our MLX by Nicholson.
Yeah.
That's kind of our.
That's the product line.
That's the product line. MLX product line.
But what's the process called that you're doing here? That's a laser.
3D printing, additive manufacturing.
Wow.
Yeah.
Love it. Brother, what's your name? My name is Vadim. Nice to meet you, man. Give you a little bit of a handshake there. We're doing a little YouTube video. But did you see the Nicholson videos on YouTube?
Not all of them.
Maybe?
Just the ones that are the main
In the main building?
Yeah.
So our team, the company that I own, we made those videos. And now we're getting a behind the scenes tour with Eric and John as well. So it's a pleasure to meet you. Yep. Well, I don't want to hold you up. Eric. I'm good to go if you're good to go.
Okay. The other component we do, the additive manufacturing MLX, is on knife arms. So previously we've soldered on carbide chiclets, and now we're starting to experiment and break into having a 3D printed material on the knife arms.
Cool.
Okay.
Very nice.
We should probably
Yeah.
get going to the ferry now.
Okay. now I got a ferry to catch and drive a whole bunch to go to my next YouTube spot.
Camping in the forest.
Well, we'll see if I'm gonna actually pull off a camping, but I did bring all my camping gear.
Okay.
Do you have any camping spots recommendations up towards Prince George, basically? Anywhere in the forest?
Well, BC does have these forestry campsites, which are free,
Yeah.
and they're often close to the highway, and you can just like pull up and.
Is there like an app or a map of them or what?
Yeah, there probably is a map. Actually, I'll shoot you like a link or something like
That'd
that.
be
You could look them up. You know what I mean?
Perfect,
And
yeah.
they're free. You don't have to re-register. You just like pull in. Camp.
That's exactly the kind of camping I'm looking for.
Yeah. Just no fires.
Okay, perfect. Good that you mentioned that. In BC, do you need like special permits to like cut trees down in the forests and stuff, or like when you're just recreational out there hiking, like?
Yeah, you can't cut down any trees.
Yeah.
Yeah, no, we would.
But if they're already down, could you?
I'll just look at our.
When it's not a fire ban, or we don't know the specifics. Like it's better to look
it
it up.
depends where you are, type thing. Like if you're on like Crown land, probably. I think it's.
Okay. Well, I'll look it up.
Yeah.
Not to put you in a
I don't
strange
wanna- I don't
spot.
want to say that.
Yeah. No, I understand. Right, Wood World. We're probably gonna close it right there. Right, Eric?
That's it. Yeah.
Hey, what do we got here? We're wrapping the video. It's still live. Anything else you want to add or throw in before I
no.
close?
I think we're all good.
Perfect.
Yeah. just
And
crack
with
it back
that,
here.
we're gonna cut. See you next time.